Hi everyone, welcome back to Lifey Technologies channel and thank you for watching. So today we are looking at an interesting part of deploying IPRAN network for service providers. So we all know the service provider network normally have thousands of devices and it's spanning multiple regions. So it's huge and you need to come up with some mechanism that can help you to improve network convergence so that when there is a failure in the network, the services will not be impacted at all, or the duration of impact will be minimal. So this is what we'll be looking at and just trying to understand which mechanisms we can use to improve network convergence. So the first part, we've already covered it, is that you need to segment your network into areas. So you have to segment your network into small areas and ensure that there is proper planning of these areas so that you don't have an entire network in one area. That one in itself will cause the convergence time to be so huge. So when you are deploying, when you have SIS protocol running on your network, there is a procedure that it follows for the network to be converged. So of course you've configured the protocol, you've configured the neighborship relationship between routers. So the first step is the two neighboring routers have to establish neighbor relationship. They have to exchange the hello packets and establish a neighbor relationship first. Once they have established a neighbor relationship, they will move to the second stage where we are having LSDB synchronization. So they are exchanging the CSNMPs and PSNMPs and the LSP information. So once the LSDB between the two routers, the two neighboring routers has been established, now they do SPF calculation to calculate the best routes to the destination. And once we have the best route to the calculation, we move forward and install these routes in our forwarding information base. So these are the 4 stages that SIS goes through to be converged. So we have establishing neighbor relationship, LSDB synchronization, SPF calculation, and then installing routes in the forwarding information base. So this is the normal procedure. But then what happens when there is a fault in the network? So when there is a fault in the network, the process changes because first we need to be able to detect this fault. We need to be able to know that there is a fault that has occurred in the network. And this one definitely takes longer time. So when there is a link or a node failure in the network, we need to be able to detect this fault, and then there will be subsequent processes or stages that we have to go through for us to be able to be converged again. So first we need to do the fault detection. We need first to detect the fault, know where it has happened, what it's impacted, what has changed in the network. And then, so this one will take some time also, depending on which protocol you are using, depending on which other mechanisms you have deployed to speed up fault detection. So once you've detected the fault, the second stage will be updating the LSPs. So routers will update LSPs, and then they will flood LSPs in the area. Once we've flooded the LSPs, we have to run SPF and calculate routes, and finally install routes in the forwarding information base. So this is the process when there is a fault in the network. Maybe it could be a node failure or a link failure in the network. So all these, we need to find a way in which we can speed up the network convergence. There are some inbuilt mechanisms in ISIS that can help us achieve this, and one of them is I-SPF, which we call the incremental SPF. Remember, SPF is the algorithm that is used to calculate routes in ISIS protocol. So when there is when you have ISIS running in your network, it will do route calculation for the entire network. But now remember, this one we are handling a scenario where there is a change in the network, there is a fault. Maybe just one link has gone down, maybe just one node is down. how do we prevent ISIS from recalculating the route for the entire network? So we use what we call the incremental SPF, I-SPF. So this one will only recalculate routes for the affected part of the SPF tree. So this one will help reduce the number of the need. It will reduce the need for many routers within the area from having to recalculate the entire topology. So we don't need to recalculate the routes for the entire topology. We only do it for the affected part of the SPF tree. Then we also have the PRC, partial route calculation. So PRC also is similar to I-SPF. It only calculates the routes that have changed, but it does not calculate the shortest path. So PRC will just update routes based on the SPT calculated by I-SPF. So these two are working hand in hand. I-SPF, then once we have completed I-SPF, we have PRC that depends on I-SPF. We also have what we call the fast LSP flooding. Sometimes we have network that requires fast LSP flooding in the network. So the device will not wait. Like when the device receives LSP that trigger route calculation or route update, it floods these LSPs immediately. It doesn't have to wait for the route calculation to occur on its local device, that is. So this one will help to speed up network convergence and LSTB synchronization throughout the entire network, because once you receive the LSPs, you flood them immediately. So this one, sometimes we also configure the timers, because you don't want these LSPs to be flooding very frequently. So we look at it in the subsequent slides. Other mechanisms to accelerate ISIS convergence speed, we have, you can configure interval for detecting link or device failures. So you can configure the interval at which two routers exchange hello packets. And then you can also specify the number of hello packets that are sent before the local device consider the neighbor down. So you can configure all these parameters based on your network requirements, the interval and the number of packets. And another way you can speed up the network convergence, especially on fault detection, is by configuring dynamic BFD for ISIS protocol. So that is bi-directional forwarding detection that helps to speed fault detection in the network. Then another mechanism is you can set flattening parameters for SNMPs and LSPs. So you can set all these parameters on your routers that is running ISIS. For example, you can set the maximum lifetime for LSPs. You can set the size of an LSP. You can set an interval at which CSNMPs are sent. And you can also configure automatic ISIS LSP remaining lifetime adjustment. So these are just some mechanisms that you can use. You can set the flooding parameters for SNMPs and LSPs. Another way you can do is to adjust SPF calculation interval. And this will ensure that ISIS will respond to network changes in time and reduce the system resources consumed by SPF calculation. So you set it depending on the stability of your network. If your network is stable, then you don't have to be running SPF multiple times. You have to wait, and then when there is need, that's when you do the SPF calculation. Then the third last mechanism is you configure convergence priorities for IPv4 ISIS routes. So some routes may be critical in the network. Maybe they are the one that they are used for some delay sensitive or packet loss sensitive data packets. network services. So you can set the convergence the priorities for such route so that we are minimizing the downtime for such kind of services. They will be the first one to converge, then others can converge slowly. Then you can also enable ISIS intelligent timers in the network. And another best practice for improving network convergence is to implement the auto FRR. So with the auto FRR, that is fast route, an IGP will pre-calculate a backup path based on LSDPs and then install it in the routing table. So once there is a network change, the switchover will be faster because it doesn't have to recalculate the route again. So ISIS supports LFA, that is loop-free alternative, and then we have TILFA and remote LFA. So these are just mechanisms that can be used to improve network convergence on a network that is running ISIS. In our subsequent videos, we will be doing a lab on how to implement these features. Remember, some of them like I-SPF, PRC, those one are default. Fast flooding, those are implemented by the protocol by default. So we really don't need to configure anything. But some other parameters like adjusting the hello timer, this one, we need to do them manually. So in our next lab, we'll be demonstrating how to achieve all these different mechanisms that can help us speed up network convergence. So thank you for watching again, and please remember to like, comment, and subscribe to our channel for more upcoming videos. Thank you.